Assalamualaikum warahmatullahi wabarakatuh. My name is Nurina Binti A.Ramlee and I would like to present my project entitled Face Recognition Using Efficienet with Squeeze and Excitation SE. This project focused on developing a biometric face recognition system using deep learning technique for identity recognition and access control applications. For the intonation, face recognition is a biometric identification technology that recognizes individuals based on their facial features. It is widely used in security system, access control, and identity verification applications. Deep learning has significantly improved face recognition performance by enabling automatic feature extraction and more accurate classification. The objective of this project are first, to design a biometric face recognition and verification system. Second, to implement an advanced deep learning model using Python and Efficienet architecture. Third, to train then and evaluate the system using a publicly available biometric dataset. Fourth, to analyze performance using accuracy, precision, recall, F1 score, and confusion metric. Fifth, to discuss the feasibility of deployment in facilities engineering applications. Next, I will explain about dataset. This project used the label face in the world LFW dataset. LFW is publicly available face recognition dataset containing image of different individuals collected under various real-world conditions. For this project, 33 identities were selected. Only subjects with at least 20 images were retained to ensure sufficient training data. The dataset was divided into training, validation, and testing set for model development and evaluation. This represents the overall system pipeline and pre-processing step of the proposed face recognition system. The system starts with the LFW dataset, which contains facial image of multiple individuals captured under different real-world conditions. This dataset is used as the input for the model development. Before training the model, the image goes through a pre-processing stage. In this stage, all images are resized to 224 by 224 pixels to match the input requirement of the Efficienet B0 model. This ensures consistency in image dimensions. Next, data augmentation is applied using random horizontal flipping. This helps increase data variation and improve the model ability to generalize better to unseen image. After that, the image are converted into tensor format, which is required for processing in PyTorch. Once pre-processing is complete, the dataset is divided into three parts through data splitting, which is 70% training, 50% validation, and 50% testing sets to ensure reliable model development and evaluation. The process data is then passed into the Efficienet P0 model, which use transfer learning with pre-trained weight. This allows the model to learn facial features more efficiently without training from scratch. The model is then trained using the training dataset validated using training and finally evaluated using the test dataset. Overall, this pipeline ensures that the face recognition system is properly prepared, trained, and evaluated for accurate biometric identification. In this project, the selected deep learning model is Efficienet B0, which is used as the backbone for the face recognition system. Efficienet B0 is a pre-trained convolution neural network that is known for achieving high accuracy with relatively low computational cost. It uses a compound scaling method which balance deep, width, and resolution for the network to improve performance efficiently. In this project, transfer learning is applied using pre-trained weak trained on large-scale datasets. This allows the model to learn general image features such as age, texture, and shape before being fine-tuned for face recognition. The final classification layer of Efficienet B0 has been modified to match the number of class in this dataset, which is 33 identities. This makes the model suitable for biometric recognition tasks, especially in applications such as access control systems and security monitoring in facility engineering. Next, for training configuration, this project, the model training process was configured using a set of optimizer hyperparameters to ensure effective learning and good performance. The training was conducted for a total of 10 epochs, which means the model was trained through the entire dataset 10 times to gradually improve its learning ability. A batch size of 16 was used. This means the model processed 16 images at a time before updating its weight, which helps balance between training speed and memory efficiency. For optimization, the Adam optimizer was selected because it is efficient and adapt the learning rate automatically during training. This helps the model convert faster and more effectively compared to basic gradient descent method. The cross interval loss function was used as the loss function since it is a multi-class classification problem involving 33 different identities. This function measures the difference between predicted output and actual labels, guiding the model to improve its accuracy. The model was implemented using the PyTorch framework, which provide feasibility for building and training deep learning models. Overall, this training configuration ensures that the model is trained effectively while maintaining good generalization performance for face recognition tasks. From the results, it can be observed that the model improved significantly across epoch. The training accuracy increased steadily from around 77% in the first epoch to above 93% in the final epoch. This indicates that the model is learning useful facial feature over time. At the same time, the training loss decreased from approximately 1.58 to around 0.09. The decreasing loss shows that the model is making fewer prediction errors as training progress. Overall, the trend of increasing accuracy and decreasing loss indicates that the model has successfully converged and learned data set effectively. For performance evaluation, several metrics were used including accuracy, precision, recall, and F1 score. The final test accuracy achieved in 93.29%, which shows that the model performs well in recognizing facial identities. The precision value of 0.95 indicates that the model has a low false positive rate, meaning it rarely misclassifies an incorrect identity as correct. The recall value of 0.93 shows that the most actual identities are correctly identified and by the system. The F1 score of 0.93 demonstrates a balanced performance between precision recall. In addition, the confusion matrix shows that the most predictions are correctly classified along the diagonal, which only a small number of misclassifications occurring between similar facial features. Next, facilities engineering deployment. The system is designed with potential deployment in facility engineering environments, particularly in security and access control systems. One of the main advantage of this system is its computational efficiency. Efficienet B0 is lightweight compared to other deep learning models, making it suitable for real-time applications. In terms of real-time feasibility, the system can be integrated with CCTV cameras for live face recognition, which can be used for door access control, restrict area monitoring, and employee attendance systems. However, there are some security considerations. The system must handle risks such as false acceptance. There is an unauthorized person is incorrectly granted access and false rejections, where an authorized person is denied access. This risk can be reduced by adjusting these whole values and improving training data quality. Regarding scalability, the system can be expanded to support a large amount of users by returning the model with additional image. For hardware requirements, the system can be deployed using standard components such as CCTV cameras, a processing unit with CPU or GPU, a database server for storing face embedding, and a network connection for system integration. Overall, the system is feasible for implementation in modern smart building and industrial facility environments. Lastly, for the conclusion, in conclusion, a face recognition system based on Efficienet B0 has been successfully developed and evaluated. The system achieved a final test accuracy of 93.29% with strong precision, recall, and F1 score values, indicating good overall performance. The result shows that the model is capable of effectively learning and recognizing facial features from the LFW dataset. Furthermore, the system demonstrates practical potential for real-world performance, such as access control, attendance system, and security monitoring in facility engineering environments. For future improvement, the system can be enhanced by using larger datasets, improving real-time processing speed, and integrating with live camera system for full deployment. That's all from me. Thank you for watching my presentation.